Hi there, this is Srikanth Azare. So in this lesson, we are going to learn about how to program queue linear data structure in C using using a structure here. Okay. So in the last lesson, when we studied about queue data structure, we have used a plain array to implement the various operations on the queue and to build a queue using that plain and simple array. So now what we are going to do is, so now let's embed or enclose all the queue variables or to build a queue ADT data type using the structure here. Okay, so user defined, excuse me, so user defined data type using a structure. Okay, so let me launch the ID. So before that, this is my YouTube channel for programming tutorials known as Dasari Tools here. Okay, so if you want, you can subscribe to this channel and feel free to comment on any of these tutorials which I have made here. Okay, so we go to videos section. You find video tutorials on programming languages like C, C++, JavaScript, SQL, um, HTML, PHP, and so on and so forth. Here, okay, so feel free to subscribe, comment, and on any video, whatever you wanted. Okay, so let me launch the IDE. So we know that we are using a Visual C++ Express edition, which is very old. Okay, so which is very convenient for us to do minimum programming. So now here I have already created a project under the name Queue data structure, which consists nothing but queue.c file. So it consists already. I have done some coding here. List I have built a menu since to save some to save some time. So if you run the program, nothing happens exactly here. Okay, so it just adds an element into a queue. Like it just displays a menu, like add an element into a queue, delete an element from the queue, display the elements, exit, and so on and so forth. Okay, so user can choose any from any choice. Nothing happens as of now because we haven't written any code here. Okay, so except if we select the choice as 4, it exits from the program. That's what happened here. Okay, so here our intention is to develop a queue data structure using a structure in C. Okay, so before that, let me write the title in the form of a comment here. So programming or coding queue data structure. So uh, coding queue data structure structure using the structure. Okay, so it sounds a little bit awkward here. Okay, it's queue data structure using the structure here. Okay, so queue is a linear data structure. As we know that it's a linear data structure. It consists of two main operations, which is adding an element into a queue and deleting an element into a queue. So if you observe in our menu, the first operation which we are going to perform on the queue is adding an element into a queue. For that purpose, we have taken case 1 here. So that's the reason I have written an add operation in the form of a comment here. In the case 2, we have a comment with the delete operation here. Okay. So let's name the functions in our program as Enqueue and Dequeue. Okay. So let's write another comment also. So on operations. Okay. So queue has two main functions or two main operations. Two main operations. So which are Enqueue. So let's name it as Enqueue here and Dequeue. Okay. So Enqueue is used to add an element into a queue, and Dequeue is used to add a delete an element from the queue here. Okay. So first, let us as we are building a queue data structure using a structure user-defined data type here. Okay. So let's take a structure here. So with the help of the keyword struct, let's say queue. Okay. Struct queue. Let's have some variables here. Okay. Let's have some let's define the variables which are very essential for the queue, which is front, and the next important variable is rear, where the element gets inserted, and the most important is an array itself. Let's say QUE, the name of the array which we are going to take in the form of a macro, since we are using macros here. Okay, so let me take the macro also. Let me say hash define max of 5. Okay, so to make it simple, let's define a macro of 5 here. Okay, So the three main essential queue variables are going to be front, rear, and the array itself, which holds the elements of the queue. Okay, so let me write a comment. Structure queue structure, or else, let's write directly queue structure. So which holds all the queue variables. Okay, so which holds all the queue variables. And now let's define each and every individual function which to do the task here. Okay, so I'm defining a variable. So the very first thing I need to do is to excuse me. The very first thing I need to do before writing the functions is I need to initialize the front and rear of the queue, like front and rear to -1 both here. Okay, so front and rear to -1 such that it states that the queue is empty. So if you run until now, nothing. Also, we have an error here. So left of front q dot front is equal to -1. Q dot rear. Okay, so we have initialized the both the q dot front and rear to -1, which states that the initial state of any queue should be empty, since there are no elements the very first time when you create a queue or you run or you perform certain operations on a queue data structure here. Okay, so now let us write the function to perform the add operation, which is going to be enqueue. Okay, so let's write the function here. So void enqueue. So enqueue is a function or an operation which is performed in a queue to add some elements in the queue here. Okay, so before adding an element into a queue, the first, according to algorithm, you need to check whether the queue is full, or whether it's is there any room to enter the elements, or it's full here. Okay, so that condition goes like this: if queue dot rear is equal to max, excuse me, max -1. So then this condition states that the queue, there is no room for elements in the queue. That means the queue is in overflow condition here. Okay, so let's say queue overflow. So that means that user can't enter any sort of element when there is an overflow condition arises here. Okay, so there is no room. The max element, the rear contains that means the position of the rear is in such a way that it's the maximum position of the rear. Okay, so that means that you don't have any room to enter an element in the queue. Okay, so this is the condition. So if it's not followed, then in the else you can have now. So in the else you can have an item. So int item. Okay, so you can now take the input from the user. So let's say something else. /t. So enter the data item to be stored. So in the queue. So, okay, so you need to be very specific when you are writing the programs such that the user does not get confused here. Okay, so let's make ourselves some room. So scanf %t. Okay, so scanf %t ampersand item. Okay, so we have grabbed the input from the user. So now what we are going to do is so before like ARR of item. Okay, like ARR, sorry, so q dot, the q is the name, so q is the name of the structure variable, so which we have taken here. So q dot q of rear, or q dot q of q dot rear. Okay, so rear, the element enters in the rear part here. Okay, so in the rear part. Okay, the element enters in the rear part here. Okay, so now there is a condition also need to be checked before directly entering the elements here. Okay, so now you can directly say q dot front plus plus since you have sorry q dot so you know sorry you haven't deleted the element here. Okay, so here you can say something like this: q dot front, sorry. So before entering an element, you need to what we call so here you have just taken the input from the user and you have stored that input item, data item in the variable item here. Okay, so before directly pushing into that or adding that into a queue, so you need to check some conditions. So which go like this. Okay, so if there might be a chance that the queue is the item which you are going to enter is the very first item which you are going to be stored in the queue. Okay, so to check that we have a condition something like this: the queue dot rear q dot rear is equal to -1 and and q dot front is equal to -1. Okay, so that means that initially the queue is empty and whatever the item you are going to enter is the very first item in your queue. Okay, so in that case you need to first increment both the q dot rear and q dot front in such a way that both are set to 0 since they are in the -1 format, q dot rear and q dot front. Okay, so front plus plus, that makes them both to set. The queue is set now, which is ready to add some elements inside. Okay, so now you can say that q dot q of uh, q dot rear is equal to item. Okay, so you have to say like this. Okay, so if it's not the case, that means there are already then it falls to the else condition. So else, so if so else you can say something like this. So if it's an else, directly you can say something like this: the q dot rear of q dot rear, you can increment the rear directly, q dot rear, and you can store the element at the position in the array at the position of rear after incrementing. So q dot q dot rear is equal to item. Okay, is equal to item. So in that way, you need to perform the enqueue operation in your queue. Okay, so if you run your program until this extent, so before that you need to have a prototype of this function at the very top. Okay, since we have defined the function after the main function here, so I'm just putting the prototype and I'm just calling the function here. So enqueue. Okay, so I'm calling the function. So here, if I select the first option here, it asks me to take some element from the user. I am taking 1. So again 1, it's 2 and 3 and 4 and 5. Now if I press 1 after entering the 5 elements in the queue, so if I again ask us, then it will share the message as queue overflow here. Okay, so let's make the output more clear. Okay, so by putting the system.sls function here, so let's say something like this: system CMS. Okay, so enter an item. Again, if you take 2, again 3, again 4, again 5. Okay, so now we have entered 5 elements, which is the maximum limit of our queue. So here we have taken has defined max of 5. If you remember, if you go to your program, we set the maximum limit of our queue to be 5. Okay, so that's the reason we are using a macro here. Okay, so in that case we have already entered 5 elements, and now if you try to enter one more element here, let's say if you take the option 1, and it's automatically leads to this condition, which is a queue overflow. So if you go to your enqueue function here, okay, so here your condition is met such that if you are encountering the max -1 element or index, if your rear is equal to the max -1, which is fourth element, which is the maximum element in your array, since array is 0 based in C. Okay, so that's the reason it's showing it as a queue overflow. Okay, let's come out. Okay, so we have done with our enqueue operation. So now let's write a function to perform the delete operation, which is a dequeue. Okay, so let me. Okay, so let's say let's take a function here, function definition, which goes like this: void dequeue. Okay, Okay, so why dequeue? So let's take another variable here, int item. Okay, so let's say system seamless to make the output very clear. Okay, so in all aspects. Okay, so before deleting an element from a queue data structure, so first we need to check whether there exists any element in the queue. Okay, so that is also known as underflow condition. Okay, so to do that, first let us write a condition here. So if front is equal to -1, okay, so which means that that there are no elements in the queues, and then there is no case in point that you are going to delete an any element from the empty queue data structure. Okay, so we need to have a message something like this: so printf /t the queue, or else you can say some simple like this. Okay, so queue underflow. Okay, so you can say something like this: the queue underflow, and then you can in the else condition, which is very important and key thing when you are deleting an element from the linear queue data structure. So first you need to have an item. Okay, so first you need to take out the element from the queue from the front part. To do that, you have to follow the following syntax: so q dot q of q dot front. Okay, so then the frontmost element directly comes out of the queue and it's placed in the item variable. So now you can say, you can have a printf statement here. Okay, so you can say something like this: /n/t /n/t the deleted element. So from the queue, the deleted element from the queue is equal to %t. So item. Okay, so here you have a deleted element. So after that, as soon as you delete your element, there arises two conditions here. Okay, so if so we keep on deleting the element in the queue, there will arise a certain condition such that the front will be equal to rear here. Okay, so rear, if you keep on adding the elements, so you increment the rear position, so such that it will be the max -1. So in the same way, if you keep on deleting the elements from front, such that the front will also meet the rear condition here. Okay, so both will be equal at one condition. So when that condition is met, again it's significant, and again it's warning signal or alarm that again the queue is empty here. Okay, so to do that, let's try that condition here. So q dot front is equal to double is equal to uh, q dot rear. Okay, so if its front is equal to rear, so then you need to have you need to keep set the front position. So front is equal to -1, and q dot uh, and q dot rear is equal to -1. Okay, so if not that case, then you can increment your front here. Okay, so if that's not the case, then you can increment your front q dot front plus plus. Okay, so this is the essential thing when you are developing a module for or a function for TQ operation here. Okay, so let's write another module also for display. So before running the program, so let's say display. So let's take a variable since we are going to run a loop here. So before display, also you need to check whether there are any elements to display in the queue data structure or not. So for that purpose, so you need to have a condition also. So if again I can say something like this: if front is equal to -1, which is the significance of the queue empty, the empty nature of the queue. So you can say something like this: /t the queue is empty. So you can say now overflow or overflow, something like this. Okay, so queue is empty. So or else, if else, you can say something like this: for that you can have a message. So printf /t the elements the items. Okay, you can say whatever you wanted. The elements in the queue are as follows. Okay, so elements in the queue are as follows. You can have a couple of slash and statements and so on and so forth. So you can say something like this: if queue I is equal to from front to rear, we need to display the contents of the queue. So you can say something like this: queue dot from front and I greater than or equal to. Okay, so I greater than or equal to q dot rear until rear. Okay, okay, so I is equal to q dot front and I less than or equal to q dot rear and I plus plus. Okay, so this is the for loop which we are going to use to display the elements of the queue. Okay, so let's say printf slash n or else percentage d slash n. Okay, so percentage d slash n and let's say q dot q of I. Okay, so since we are using the variable I to display the elements here. Okay, so this gives you the list of elements. Okay, excuse me. So let me add the system CLS function here also, so such that it's the output will be a bit clear. Yeah. So let me have the prototype for this as well. Okay, so at the beginning, so for display and also let me write for Dequeue also. So Dequeue, right? And now what I'm going to do is, so I'm just calling the both the functions which I have just now defined both of them. So first one is Dequeue. So why Dequeue? So I'm display here. Okay, so display. So here we have both the functions called. I'm just running the program. Oops, we have an error here. So somewhere we have did a silly mistake. Go. So q dot front, instead of using q dot front directly, it can't access the structure variables. Okay, so that's the error. Again, we have an error. One more error. Front legal. So the else condition. So closing the else condition here. So again, q dot front. If I'm not wrong. Legal else without if. Okay. So it's saying that we are using a if statement here, and we are not supposed to have a printf statement in between, according to some situations based upon the IDE we are using. What's happening here? Interesting. Okay, so now let's. Okay, so now let's run the program. So everything goes well. Here we have. So I'm taking just the first option here. So entering all the elements in the queue. Okay, so one by one. Okay, so I have entered all the 5 elements. So I am taking the display function. Oops, we haven't had any display items here. Okay, so let's see whether the delete is working perfectly. So we are getting all the delete elements. So queue underflow. So display, there is a flaw. Let's see what happened, what went wrong here. Okay, so let's go to our display function here. Print out the elements in the queue. I is equal to front. I less than or equal to q dot rear. I plus plus and q dot q of I. So q dot q of I. Okay. So front is equal to q is empty. So display. Hope we have called the display function here. So everything went well. So even though we're not getting, interestingly, yep, I figured it out. So here we have we need to call the display function inside the case 3. We have did a blunder mistake of calling that in the case 4 here. Okay, so to exit from the program, that's what the comment here, which has been removed. Okay, so now if you run your program, everything goes well. If you press the display for the very first element, it gives you the message that queue is empty. And if you take the first operation, which is an enqueue operation to add the elements in the queue, so let's keep on adding the elements. Okay, so now if you display your elements, you have your elements in the queue displayed. So now if you keep on deleting the elements by pressing the option 2, so you get all the elements deleted in the queue. So last element, when the last element is deleted, so if you try to perform the queue delete operation once again, it should throw the underflow error here. Okay, so that's the reason it's showing it as underflow here. Okay, so this is the basic stuff about so how to perform how to build a data structure, queue data structure. Okay, using the structure here, and it has two main operations, so enqueue and dequeue. Okay, so okay, let's place the comment here. Okay, the structure. Okay, the queue data structure holds all the okay, so friend, so holds the value. So I'm writing this, I'm just writing a comment here. It holds the value of friend position, okay. So rear, the rear variable holds the value, of rear position. Okay, so array holds the actual data, the array to hold to hold the actual contents or actual data of the queue. Okay, so here we have all the three prototypes of the functions which we have defined here. Okay, so the first function, enqueue function, to perform the add operation. Okay, so definition, let's write a comment here. So definition, so the enqueue function to add items or elements, in the queue. Okay, so definition of the dequeue function goes here, so you can have a comment also. So definition of the dequeue function to delete an element from the queue. Okay, so delete an element from the queue, and finally we have display function. So function, let's write a comment directly. Function to display the contents, function definition, or its function to display the contents of the queue. Okay, so we have three function definitions. We have called appropriately according to the operation, and we have called accordingly in the particular case statement. Okay, in the case one, we have since we are intended to perform the add operation, so we have called the enqueue function here. Okay, so as soon as you call the enqueue function, automatically the control jumps to the function definition area, and it keeps on executing the code, and as a result, we are able to add the elements in the queue. Okay, so as in the same way, so in the case 2, we are intended to perform the delete operation from the queue. So that's the reason we are calling the dequeue function here. So dequeue function, the sole purpose of the dequeue function and the definition itself, it deletes an element from the queue, and it updates the positions of front and rear variables accordingly here. Okay, so here you have an else condition, you have a special condition arising here. If you keep on deleting the elements in the queue at some situation, both the rear and the front values will be the same, and again you need to set the variables, the front and rear queue variables to -1, such that it indicates that queue is okay. So in the same way, we have a display function here. So the sole purpose of the display function is to display the contents of the queue. So again, according to the algorithm, you need to first check whether there is are there any elements in the queue to display. So if that's not the case, in the else condition, you need to we have used a for loop to grab all the elements from the queue, starting on the front until the rear, and displaying them using this printf statement here. Okay, so this is the way. So how to code a data structure using code a queue linear data structure code a queue linear data structure using a structure here. Okay, so this is the basic stuff. So see you in the next lesson.